Okay, so let's talk about the last one that we are talking about. That is using the MOSFET. Alright, MOSFET itself, just take note, is that it uses voltage, not the current. Alright, it requires a base voltage, or you can call this a gate voltage. Alright, and we can write it as a VGS. Alright, and then lor. So it works the same way. So if your voltage over here is larger than the required one, then you open up the gate and allow the load to flow in. Alright, or allow the source. Okay, I think the source is coming in from here, I think. Alright, and you actually flow towards the load. I don't know, let you think about it. But anyway, at least you get a feel of how the MOSFET is worked in a very lousy way. But just take note, the keyword is that the MOSFET is controlled by the voltage, threshold voltage, rather than the current that is for the previous two methods, the NPN and the dilatant pair. Alright, thus no current flows in a steady state for the voltage, because your voltage is always constant, I think. So therefore the current doesn't have any fluctuation. Alright, so no fluctuation means thus no current flows in a steady state. Only when the voltage changes. Yeah, so if you constantly supply a steady voltage, your current wouldn't change. So why do we want current not change? Is because the current will actually fluctuate, and this may actually cause system failure and things like that, which in this case the MOSFET itself allows a constant steady state current. Therefore this fluctuation and things like that will not affect your devices. So this is why it makes them very attractive device to use for your whatever transistors lah. Alright, and I think you get what I mean already lah. Alright, so MOSFET is one thing that you may want to consider compared to the NPN. Alright, but I think basically it is used for the construction of digital integrated circuits. Alright, so compared to NPN, you're actually used for the load. For the MOSFET, I think it's used within the IC itself. Okay, so something that you may want to also consider. Alright, and so I think this is it for what we know. Alright, and but however, you may have a problem with your whatever transistors that you're using, is because they may have certain inductance. Alright, many loads are inductive, alright, because they have inductors within themselves. Alright, I forget how to draw it. I think it's this symbol. Alright, yeah, inductor. So motor, transformer, whatever, they got inductor, and the inductor itself, if you remember, it collects current, or it stores voltage. I forget already, but anyway, in any sense, it will actually have a back EMF. Alright, so when they are turned off, the BMF will actually surge. Alright, and the voltage will actually go in the opposite way, and then you'll go back up to actually spoil your load and also your microcontroller. So therefore you need a protection. Alright, so the protection is to protect the back EMF from your inductor. Alright, and therefore you requires a suppression diode, alright, over this side and this side. So you requires two diodes. Alright, so the second one over here is for extra protection. Alright, this one is definitely you must require a one that is connected parallel to the load. Alright, so this is something that you need to know lah. Alright, the diode is connected parallel to the load. Alright, while another diode is connected parallel to the collector emitter system. Okay, so for example, this is normally we run our load like that. Alright, and then we write it like this, right? Yeah, okay, so over here what we do is to draw one more diode over here parallel, and you draw one more diode over here parallel. Okay, that's all. Okay, so this is the one, and this is another one. Right, so normally if they ask you to draw how to protect your system, you can draw in this manner. Alright, and these protection diodes are often called the digital transistors. Alright, so protection diodes are built into most drivers and sometimes the base resistors as well.
So these are sometimes called digital transistors. Alright, so just to take note of that lah. Okay, I think that's all. So before we go into the motor side. Alright, so yeah, see you soon.